Army materiel must operate reliably in any environment. Trucks, guns, tanks, and rockets must be capable of functioning in all types of global environments. Desert sands, rocky ground, mountain slopes, mud, jungle, snow and ice are terrains over which men and equipment must travel, or where combat operations may take place. The operational success and tactical usefulness of Army materiel is the result of constant progress in research, development, design, engineering, controlled testing, laboratory analysis, and evaluation of field results of Army materiel. This responsibility is designated to the United States Army Materiel Command and all its subordinate commands, one of which is the United States Army Test and Evaluation Command, which includes Yuma Proving Ground. Yuma Proving Ground is located on the edge of the Yuma Desert. This area provides an unusual variety of terrain and the highest ambient temperature for prolonged periods to be found in North America. Here, the highest priority of effort is placed in research, development, and testing to assure quality and reliability of materiel to the user. Yuma Proving Ground is located approximately 30 miles northeast of the city of Yuma, Arizona. The main reservation contains approximately 870,000 acres. The Proving Ground boundaries form a horseshoe around the Kofa Game Refuge, a vast uninhabited area. High ambient temperatures, which reach extremes of 120 degrees Fahrenheit between May and September, make this the most severe desert environment in the United States. During the remaining part of the year, the desert is conducive for outdoor living. Most people take recreational advantage of the abundance of sunshine and low humidity. These conditions assure year-round test operations with minimum interference from adverse weather conditions and permit a dependable daily schedule of test programs. To evaluate the suitability of United States Army materiel, Yuma Proving Ground conducts mobility, munitions, weapons, rockets, and air delivery tests. Types of tests conducted are engineering, engineering design, quality assurance of production items, and product improvement. Vehicles, their components, and related equipment are tested on 21 established courses for various types of performances. Some of these courses and their purposes are dust course, to determine vehicle and components wear and operation in extreme dust conditions. The cross-country course, consisting of ruts and bumps, to obtain durability and reliability data. Alkali flats, to study component susceptibility to corrosion. Truck cross-country course, to obtain cross-country durability and reliability data on wheeled vehicles. Gravel course, for determination of temperature characteristics of vehicle steering systems. Dry washes, to record performance of fuel system under high temperatures and heavy load conditions. A 2.5 mile truck hill course with grades to 20% obtains wheeled vehicle durability and reliability data. A 5-mile tank hill course with long slopes up to 35% determines tracked vehicle durability and reliability performance. Rock ledge course tests adequacy of the vehicle component mountings. The boulder course is used to determine a vehicle's mobility over extreme rocky terrain. The standard obstacle course consists of a bridging device expandable to 8 feet, vertical walls to 48 inches, and a simulated standard shell hole. On a 50-mile section of U.S. Highway 95, wheeled vehicles in convoys can operate 24 hours daily with a minimum of traffic interference. 30 miles of controlled gravel secondary roads are also available for convoy use. An isolated 5-mile section of highway adjacent to the proving ground is available for testing oversized vehicles. The dynamometer course with turnarounds at each end is 2 miles long and 30 feet wide. Constructed of high-strength asphalt, it is used for full load cooling and other selected performance tests. A sand dynamometer course, 900 feet long, is used for selected engineering performance tests in sand. Prepared sand slopes with grades from 10 to 30% are used for mobility studies of vehicles and tire evaluations. 20 and 30% side slopes are used for checking vehicle stability. 30, 40, and 60% surface slopes are used for determination of vehicle ability to ascend and descend grades required by U.S. Army standards. A mud course consisting of sand, silt, and clay has a regulated water supply to control moisture content and produce desired conditions. A fording basin is available with controlled water depths. Clear Lake, adjacent to the proving ground, has a maximum depth of 15 feet and is used for checking performance of vehicles requiring only limited fording depth. Senator Wash Dam, a local flood control and storage reservoir with depths to 50 feet, is used to evaluate swimming performance of vehicles. The nearby Colorado River offers controlled water conditions, which can simulate stream velocities of rivers in various conditions. A 23,000-acre sand dune and plain complex in the Yuma Sand Hills in nearby California is controlled by the proving ground. This area provides a variety of dune formations with natural slopes up to 60%. Other off-post test sites are used. One of these is 183 miles of highway in Death Valley National Monument Park. These roads have grades from 8 to 14% and are up to 16 miles long at elevations from 8,400 feet above sea level to 200 feet below sea level. Air temperatures over the valley floor frequently reach 125 degrees Fahrenheit in the summer months. These conditions tax vehicles to their maximum performance capabilities. Oatman Hill is a 14-mile stretch of asphalt surfaced highway between Topak and Oatman, Arizona. It is used for testing overwidth and overweight vehicles, which exceed maximum highway road limitations. Vehicle steering and braking system are evaluated on the long and short grades, ranging from 6 to 9%, which include many sharp turns. High-altitude testing of vehicles is accomplished at Navajo Army Depot, Flagstaff, Arizona. This site has paved roads to elevations of 8,500 feet. Roads, trails, and mountain slopes at elevation to 10,000 feet in the immediate vicinity of the depot are used for grade mobility tests. A variety of automotive support facilities are available at the proving ground, including test vehicle maintenance and repair, a dust-proof tear-down room, machine, welding shop, and laboratories for both petroleum and chemical analysis. Located adjacent to the Laguna airstrip are facilities for the complete preparation of air-delivered materiel and airdrop systems. Here, parachutes are inspected, maintained, packed, and rigged on drop loads in preparation for durability and reliability testing of equipment and material. The instrumented controlled impact drop facility is used to simulate ground impact of an airdrop load to determine forces and strains a test item will experience during actual delivery. The air test facility has 3 drop zones: an improved drop zone for personnel parachute testing, one for munitions, and the third for heavy cargo drops, such as this 35,000-pound rigged load containing the Sheridan Shillelagh. Each drop zone is optically and electronically instrumented for recording data on engineering and engineering design tests of air-delivered materiel. After airdrop, the materiel is inspected and tested for operational capability. Vehicles, munitions, weapons, and chemical items are airdropped and then functionally tested on various courses or ranges to determine the effect of ground impact and efficiency of the drop system employed. Engineering, engineering design, acceptance, and surveillance tests of munitions and weapons are conducted at the COFA firing range area. The 60,000-meter firing range is capable of accommodating the largest caliber artillery weapons, such as the 175-millimeter gun, and Honest John and Little John rockets, with assurance of recovery. 4 surveyed impact fields are used for recording terminal ballistic events. Each field is equipped with 24 camera positions to record functional data on munitions. The range is provided with observation posts and communications. It is instrumented with a range timing system, a Doppler velocimeter, ultra-high-speed cameras, cine-theodolites, both stationary and mobile, and radar tracking equipment are used to obtain in-flight data. These data are used to determine space position, velocity, acceleration, and event information. Time, pressure, recoil data, strain, and shock are also evaluated. Capabilities exist to assess the performance of fire control instruments and evaluate rocket launch data. Data reduction is provided by in-house capability and by contract. Some of the physical test capabilities include radiography and using X and gamma radiation, ultrasonic testing, magnetic particle inspection, dry and wet methods, and bore scoping with quick-look cameras to obtain record of tube condition at various intervals. Physical measuring devices include moments of inertia, static and dynamic balancing. The firing range area contains various types of facilities used for support of test firing programs, Some of the facilities include an ammunition assembly plant, artillery maintenance shop, range control tower, chronograph building, and mobile conditioning chambers. Meteorological services provide data in support of test operations and United States Weather Bureau programs. The desert area has a low population density, which permits detonations of large amounts of explosives or toxic agents. Adequate land areas are available to perform field trials on chemical agents being developed or under test. The Cibola Range area includes an aircraft armament range. Terrain and space are suitable for moving targets, and an air-to-ground missile target range for use by high-performance aircraft. An instrumented drone complex is equipped with facilities for assembling, testing, launching, operational control, and recovery of 2 separate drone systems simultaneously. The flight range consists of optical and electronic instrumentation for acquisition of flight data. YPG has the capability for testing fuel and water pumping units, hasty storage petroleum tanks, and mobile and stationary power generating equipment. Specific areas are designated for environmental storage of ammunitions, mines, rockets, and chemicals. One of the most valuable assets of Yuma Proving Ground is the airspace it controls. The first of 3 airspace areas extends from 1,500 feet above the surface to 20,000 feet, except in the dark area, where control extends from the surface. This area is primarily used for drone flights. The Cibola Range airspace extends from the surface to 24,000 feet. It's divided into 2 areas for control purposes. The Cofa Range airspace extends from the Colorado River eastward for 56 miles and is 12 miles wide. The unlimited vertical height is the one reason why Yuma is the only United States site capable of firing the HARP. Laguna Army Airfield has a runway 5,000 feet long and 150 feet wide. Fixed and rotary aircrafts are used for the support of various tests. Services include support of avionics, air delivery, photo reconnaissance, rocket warhead recovery, medical evacuation and air rescue. This facility and these services are used by or available to tenant activities. The proving ground is used by other services for training and for service testing of munitions, weapons, vehicles, and electronics. This vast area, with its instrumented ranges, varied terrain, extreme ambient temperatures, solar radiation, test courses, airspace, unlimited visibility, optimum tracking, and assured recovery of test items, offers a broad scope of test facilities, rarely centralized in a single area. Professional engineers, skilled technicians, both civilian and military, plan, execute, and report on all tests. These combined advantages make Yuma Proving Ground an ideal test and evaluation facility, serving the Test and Evaluation Command and Commodity Commands of the United States Army Materiel Command.